Hello, my name is Yaroslav Volkov, and I'm going to present my exam for the class of Intermediate Mathematical Modeling with teacher Jorge Becerril, group 409. We got two problems that we're going to solve. The first one is related to Captain Ralph, which he has a function, which is this function. We got a point, this point, and we want to know in which direction the temperature is decreasing, and we want to know the speed which it travels at. So we know that towards t, towards this t, we know that it's decreasing. So also another thing that we know is that the direction of fastest increase is towards the gradient. So if we want to know which direction is decreasing, we're going to have to do the opposite of the positive gradient, which is going to be a negative gradient, which is exactly what we got right here. We're going to obtain the partial derivatives of, well, x, y, and z. We want to know with respect of this equation right here, those values. So let me clear all this. I got to do it fast because time is not working out very well for me. And we're going to get exactly our evaluated in our free constants right here. And what we're going to do is remember that we want to obtain a negative gradient. We're going to apply this negative right here, and we're going to end up with this positive value. This right here is the direction which it's heading towards Captain Ralph. Now we're going to obtain the norm of the volume, and we're going to have here the 0.111 elevated square root, and we're going to have a square root of 3. We're going to then get the direction derivative, and we're going to, these values right here of 0.00495, these are simply the values that we had up here of for 2e, 4e, 9e. And we're going to multiply that by the 1 over square root of 3. We're going to obtain these values, these three numbers right here. We're going to add them up, and we're going to multiply it by E8, and we're going to obtain our speed, which is 64 meters over second. Now, if we go check this out on GeoGebra, we're going to see that it makes sense. We got our point P, and we got our direct, where it's heading towards A, is going downwards towards the negative gradient that we obtained. So all of this makes sense. We can imagine that around here on P, somewhere along here, it's Mercury. Now, going with the next problem, we got this function of 0 and x, it goes from 0 to 4, and also on y goes 0 to 4. So I initially thought we had to do something with the volume of a spherical dome, because I was thinking about domes and all that, but it didn't have anything to do with that. I just remember that's the Boolean functions, which is just, it says right here. And it works with the Boolean function because we got exactly the xy for the function and the xy for the volume. So we're going to start first integrating with respect of y, and then we're going to integrate with respect of x. Then we're going to add the functions, which is right here. What I got with this drawing right here. We're going to add the function gx and the function cy, which this doesn't really matter because it's going to equal to 0. Here I got the full thought process of that. It's going to be equal to 0. It should be negative. I put it positive. It really doesn't change anything because it's going to be 0. So simply want to substitute the values of the values from 0 to 4 that we got up here, and 0 to 4 from y. So that's exactly what we got right here. We got from 4s, and we got our 0s. We evaluate all this. This second part doesn't really matter because it's going to be all 0. And we got our final volume was going to be 64 cubical meters. That's the capacity of the water tank. So this is the thought process for the two problems. Thank you very much.